So let's talk now about the first three rules that are introduced as equivalence rules. In some ways, I think of these rules as the ones that are just no-brainer rules. They're so obvious that it almost feels like, why do we even have a rule to state these things? However, in logic, we don't make even the smallest change without a rule that justifies or confirms that this will absolutely preserve truth. So we introduce them and we use them to make sure that our proofs are in fact, or the arguments that we prove are in fact valid. All right, so the first one is double negation. Now you've understood the idea of double negation ever since elementary school math. And the notion is this, that if you have some formula P, that is logically equivalent to the double negation of that same formula. And if you have a double negation of a formula, then that's the same as dropping them. You might almost think of it in terms of every formula that you ever have has two invisible double negations in front of it. And you can use the rule to make them visible. Or you can make them go away if you have them already in front of you. So similarly, if you had, say, for whatever reason, you'd been working out in your proof and you ended up with a line with three negations for some formula Q, you could then on the next line drop two of them and just have not Q. And that would be from line 1, double negation. So double negation allows you to make the two additional negations visible or to make two go away at any time in a proof. As usual, you can apply the rule not only just to a single letter. These formula patterns, or I should say these patterns, are such that the P's and the Q's stand for any well-formed formula. So it didn't have to be a single letter. It could have been something like, maybe you had in a line, if R, then S. You could then say in the next line, it's not the case that if R, then S, and that would follow from line 1. Double negation. Just remember that. I know it's easy to forget that you can apply these rules to more complex formulas. All right, let's go on to the next one. Again, that seems so obvious, but we're going to introduce this rule to justify this move whenever you need to make it in a proof. The rule is called commutation. We'll abbreviate it COM. And just as something to keep in mind, it applies only to conjunctions or to disjunctions. Doesn't apply to anything else. You can't do what we're about to do to conditionals or biconditionals, but you can do it to conjunctions and disjunctions. Basically, it allows you to flip the order. So here's the pattern. If I have P and Q, that is logically equivalent to saying Q and P. I know, shocking, right? So if I told you, at lunch today, I had both a hamburger and a hot dog. If somebody later said, did you know that Dr. Smidley at lunch had a hot dog and a hamburger? They've said something logically equivalent. They mean the same thing, and we're allowed to make that switch. We can apply it to conjunctions. We can also apply it to disjunctions. P or Q is logically equivalent to Q or P. So anytime you need to switch it around in your proof, if you had in some line of your proof, I'll make it more complex this time. If R, then S, or W. If you needed to flip that around, you could then say in line 2, W, or if R, then S. Notice I've taken this statement, the main operator being a disjunction, flipped it around. And that would follow from line 1 and the rule of commutation. Excellent. All right, third rule, which I think probably at times seems obvious, but we will have the rule to add it, is the rule of association. And the rule of association also applies to conjunctions and disjunctions. And it looks like this. If you have something like P and Q and R, that is logically equivalent to saying P and Q and R. Now notice all we've done here is we've moved the parentheses. And if you think about what it means to say something like this, you can have statements that have multiple conjunctions going on. You could say, for lunch today, I'm going to have a hamburger and a hot dog and a Coke. Now we have to have the parentheses in order to have a well-formed formula and to identify one of these as the main operation. But since they're both conjunctions, it really didn't matter which order it came in or how the parentheses were grouped around it. But if we get the premise listed one way and we want to make a change, we justify that change by the rule of association, and then we can apply it here. I should note here too that when you're applying rules in a proof, you cannot apply more than one at a time. So let's say you needed to switch the order and move the parentheses. You would need to take one step and do association, and then the next step to do the rule commutation, or vice versa, whatever you're needing to do. But you can't apply two rules on the same line. Similarly, this applies to disjunctions. So if you had, I'll use different letters, I guess this time, A or B or C, and you needed to move the parentheses, you could, by rule of association, say A or B or C. Of course, you can go from this side to this side, or from this side to this side, because these are equivalence rules. Keep in mind, because this is an easy mistake that people often make, the operations have to match. If you had a statement that looked like this, A and B or C, you cannot apply association to this and move the parentheses. Not okay, but it is okay on these. So those are our first three equivalence rules. Comment here if you have any questions. Thanks.